is use a calculator to evaluate the expression. Express your answer in both degrees and radians. And then the first one is sine or inverse sine of 0.766.
What does it say to do? Just express the answer in both radians and degrees?
Yeah.
Do you have a TI-84?
83.
Just this good. Hold on a moment. I got me a new toy. A virtual TI-84.
Yeah, that's what our teachers use in class.
Okay. So, if we want to take the inverse sine, hold on a moment. The one problem with this thing is that I can't quite read the keys. The inverse sine is above sine, so second inverse sine 0.766, and it gives me my answer, and the mode that I'm in is degrees.
All right.
So that's 49.996 degrees. Now, what did they tell you about the domain? Did they say that the angle had to be between 0 and 2 pi?
No.
Because there's actually multiple answers for this in degrees. In other words, we know that sine is positive in the second quadrant also.
Yeah.
So another answer is 130.004 degrees. In other words, the supplementary angle.
Yeah.
Okay. So those are the two angles in the unit circle that are in degrees. Now, of course, if we want to put it into...
I have it in radians.
Okay.
It's 0.872.
You want me to check it? Inverse sine of 0.766. What'd you get?
I got 0.872 for some reason.
Let me do it.
But we put in the same.
Hold on,
you
I
put
put
in
in sine. It didn't catch the second. I hit the wrong key.
Yeah.
Okay, 0.766, 0.872 in radians. Now, what about the second quadrant angle in radians?
Would it be? I don't know.
Well, that is an angle there, 0.872 radians. And we know that the supplementary angle is pi minus 0.872. So that would be the supplementary angle.
Oh, okay.
So let's see, how would I get that? If I subtract pi, pi is that key there. Let me try this real quick. I get 2.26, which is in our case going to be positive.
You did 0.872 minus pi, not.
That's correct. And so I know that my answer is the negative of this. In other words, what I should have done was pi minus that answer, right?
Yeah.
Well, the answer minus pi, and then I just took the negative of it. So
yeah.
2.26899 should be the supplementary angle. remember that when we're dealing with sine, we are in the calculator gives us the first quadrant angle, but we know also that the second quadrant angle is also positive. So when we're looking for inverse sine, the calculator for positive angles is going to give us the first quadrant. For negative angles, it's going to give us the fourth quadrant for sine, inverse sine. Okay?
Yeah.
So you will never come up with the second quadrant and third quadrant angles on your calculator. You have to figure those up manually. And it's easy enough to do. The second quadrant angle is supplementary to the first quadrant angle. And same with the third and fourth.
Yeah.
Okay.
Alright, next one is inverse cosine of 0.479.
Okay, now let's talk about cosine for a minute. Cosine, when they give you a positive number, our answer is going to be in the first quadrant. When they give you a negative number, our answer is going to be in the second quadrant, because cosine is negative in the second. But if we wanted both angles for this particular problem, we need to come up with the first and the fourth, because the fourth is also positive. And the fourth is merely 2 pi minus this one. So, let's see, cosine is, well, that's in radians.
And it's 61.379 in degrees. 61, not 9. Wait.
What's the other angle where cosine is equal to 0.479 in the unit circle? A lot depends on the domain here that they give you. In other words, I'm not sure what they're looking for as an answer, whether they're looking for just the first quadrant answer or whether they're looking for all answers in the unit circle, or whether they're looking for all answers, maybe in an infinite number of unit circles. You understand that it's periodic. You don't have just one answer for the inverse cosine of 0.479. You have a first quadrant answer. You also have a fourth quadrant answer. What would the fourth quadrant degree answer be?
It would be 360 minus 69, or 61.
Yeah, so what is that? 258.621. In other words, we took 360 degrees minus our first quadrant angle. So to do the same thing to figure out the radian answer, you could convert that to radians, for one thing, 258.
It's 298.
What's 290? Oh, it's 298. Yeah, sorry. So we could convert 298.621 to radians, or we could take 2 pi minus our first radian answer and come up with that. Well, what is that? Let's see. 2 pi minus 1.0712. So the fourth quadrant radian answer is 5.212. And that's the one that should match that 298. Now, let's just see if it does. If we convert 298 to radians, we're going to multiply it by pi divided by 180. 5.2. All right.
All right.
Now, just for reference sake, if we're dealing with inverse tangent, and I gave you a positive number, what quadrant are we going to end up in?
The first.
The first. The calculator will give you the first. If I gave you inverse tangent and gave you a negative number, what quadrant is it going to give you?
The fourth?
Yeah, it's just like sine. Its primary quadrants are first and fourth. Unlike cosine, whose primary quadrants are first and second.
Yeah.
All right.
All right, the next one is find the exact value of x without using a calculator, and it's sine of x equals 0.5, where pi over 2 is less than or equal to x, and x is less than or equal to pi.
Which quadrant does that place it in?
The first quadrant?
Pi over...
Oh, no. The third, or second.
Second quadrant, okay. So, how do we get the angle? Let's first of all come up with the angle. I'm particularly fond in trig of doing everything in first quadrant and then converting once you know which quadrant you're supposed to be in. So,
yeah.
If I want to solve for x here, what do I do?
Take the inverse sign of 0.5.
Okay, what's that?
I don't know.
Good one to memorize. If you're going to memorize any trig function at all, memorizing the sine of 30 degrees is equal to 1/2.
Oh, yeah.
Okay? So that would be the first quadrant angle.
So then it's 150.
That's the second quadrant angle. And also 30 is pi over 6 in radians. What is 150 in radians?
It's 5 pi over 6.
Yeah. I like to think of it as that it's pi over 6 short of, it's pi minus pi over 6. Just give you that 5 pi over 6. Okay.
Next one is cosine of x equals root 3 over 2, and 0 is less than x, which is less than pi. So it's in the first two quadrants.
It's in either the first or second quadrant.
Yeah.
Okay.
And it's going to be 30 degrees again.
Right. Or pi over 6. That would be the first quadrant answer.
So it's either 30 or 30 or 150
Hold
or
on,
5.
hold on. It's not 150 because what's the cosine of 150? Is that plus or minus?
Oh, that's minus.
Correct. So the fact that they told us that it was plus, even though they told us that it was in either the first or second quadrant, we know it's in the first quadrant. So I can actually do that. I know that x is in the first quadrant. Merely because it's positive. So the only answers are 30 or pi over 6.
Yeah.
They're just trying to fool us by making it in either of those two. Now, if this was sine, then we would have two answers because notice that both the first and the second quadrant are positive. So we would have to put both the first quadrant answer, 60 degrees, and the second quadrant answer, 120 degrees, if that was the problem there.
All right. Next one is tangent of x equals -1, where 0 is less than or equal to x, which is less than or equal to pi.
Again?
And we know it's the second quadrant because tangent is positive in the first quadrant.
Yes, and it's also negative in the second. So I can basically say this goes from pi over 2 to pi, which puts it in the second quadrant. So what is the first quadrant angle that we would be looking at if it was positive?
I don't know.
Well, let's refer to our two triangles. This is our 30/60, which is it's 1 square root of 3, 2. And the other important one is the 45/45. And when they say do these without your calculator, you know that it's one of these angles.
So is it 45?
Yeah. In other words, we can tell that the tangent of 45 is opposite over adjacent, which would be 1. So the first quadrant angle would be 45, but we're in the second quadrant, so what's the angle?
Negative.
Not negative. It's a positive angle.
It's
supplementary.
135.
Right. It's supplementary to that first quadrant angle.
Yeah.
Okay. And the first quadrant angle would have been 45 or pi over 4. This one is 135 or 3 pi over 4.
Yeah.
So there's your answer there.
The next one is secant x equals 2, where pi is less than or equal to x, which is less than or equal to 2 pi.
Okay. What's the reciprocal to secant?
Cosecant?
No.
Sine?
Let's go over this on how to memorize this, because this is important. Our three primary functions that are in the calculator are these three, right? The one we know for sure is the reciprocal of tangent is what?
Cotangent?
Which leaves the secant and cosecant to go with the sine and the cosine, right?
Oh, yeah, it's 1 over secant, cosecant.
The reason being is that every pair has one co in it. There's the co in that, there's the co in that, and there's the co in that. If you pair up secant with sine, you won't have a co in it. So you know you've done it wrong. And these are the only two you have to figure out as to which goes with which. Okay.
So the inverse would be 1 over cosine?
Well, what I can say here is that the cosine of x has to be 1/2. For me, it's easier to translate them to the three primary trig functions as quickly as possible. I just don't think good about secant, cosecant, and cotangent. But I do think about sine, cosine, and tangent. In other words, I have this memorized. I know where cosine is equal to 1/2. What's the first quadrant angle where this would be true?
60 degrees.
Okay. What quadrant are we in based on this restriction here?
Fourth?
Yes. We're in either the third or the fourth, and cosine is positive only in the fourth. It's negative in the third.
Yeah.
So we know we're in the fourth. So what's the equivalent fourth quadrant angle for x?
It's 300.
Okay. This would be pi over 3, so this would be 5 pi over 3. So there's your answer there. In other words, I take everything through the first quadrant, but you got to be very careful not to include this as your answer. In other words, I cross that out after I use it. I use it merely to come up with these other angles easily. Now, if you have a memory that has allowed you to memorize the entire unit circle, more power to you. If you can do that, do it. But personally, I think that's a very tough way to go.
Yeah.
I work everything off of the first quadrant, and I've got the first quadrant memorized for pretty much all 6 trig functions for any of these common angles that are multiples of 30 or 45. And once you memorize the first quadrant, you can translate to the other quadrants actually quite easily.
Yeah.
Okay.
Next one is cosecant x equals -1, where 0 is less than x, which is less than 2 pi.
So this is everywhere in the unit circle. So what's the first thing we should do here?
Convert it to sine.
Okay. So what sine of x should be equal to what?
-1.
Correct. The reciprocal of -1 is -1. Okay. Now the easiest way to answer this is to actually draw the sine curve out. Because there's the full unit circle. And unlike most values that have 2 different places in the unit circle, this only has 1 spot in the unit circle where it's equal to -1. Where is that?
Yeah. It's at 3 pi over 2.
Yeah. Or 270 degrees.
Yeah. Next one is cotangent of x equals -√3, where 0 is less than x, which is less than pi.
So first 2 quadrants. Which quadrant is it in? First or second?
Second.
What's the next thing I should do over here?
Convert it to tangent.
Okay.
So tangent of x equals 1 over pi of 3, or root of 3, -1.
Yeah, and for the moment, I don't really want to rationalize that. You see why? Sometimes it's better to have that thing in the denominator than it is in the numerator, and I'll show you why in a second here. It's clearly that triangle, right?
Yeah.
Which angle is it?
It's 30.
Right. Notice that had I rationalized that, had I gone to the trouble of rationalizing it, it's not as recognizable that that's the 30-degree angle. Because after you rationalize it, it doesn't fit these dimensions that I use.
Yeah.
The same number, but it's not as recognizable. So that's why I don't rationalize it immediately. As long as I leave it as 1 over root 3, then I recognize instantly that it's the tangent of 30 degrees. So 30 degrees is our first quadrant angle. What is our second quadrant angle that we're looking for?
Our second quadrant angle would be 150.
Or
5 pi over 6.
okay. Pretty good workout on your 6 trig functions, your inverse trig functions.
Yeah. In exercises 85 to 88, evaluate the expressions without a calculator.
Okay.
And it's tangent of quantity inverse tangent of 1.
Okay. Whenever you're doing these like this, there is a short way to do it. But let's make sure you understand exactly how to do it the sure way. The sure way is to work from the inside out. In other words, what is the inverse tangent of 1 equal to? And we want the primary answer. We want whatever the calculator would give us. So that's 45 degrees. In other words, we would not want the the third quadrant. The third quadrant would be 215.
Yeah.
In this case, it's not going to matter, but we will see some here that it will matter. So working from the inside out, the inverse tan of 1 is 45, and what's the tan of 45?
Root 2 over 2.
Oh, tan of 45 is 1.
Oh, yeah.
Right? So we could have actually said that the tan of the inverse tan of 1 is equal to that number, 1. The problem is that won't always be the, it might always be the case if these two things are the same function. But if you start mixing up functions, in other words, if you took the tan of the inverse sine of something, it might be a little different. You can't always assume that this is your answer.
Yeah, and the next one is actually tangent of quantity inverse sine of 3/5.
It's actually an easier way to do this one. You're supposed to do this without the calculator, correct?
Yeah.
Okay. Let's draw a triangle. And label theta. When we take the inverse sine of a number, we're going to get an angle, right?
Yeah.
Let's call that angle theta. That allows me to dimension this triangle that much of it right now.
Yeah.
What's the third side?
The third side's 4.
Okay. So now, what is the tangent of theta? And I don't even have to know what theta is.
3/4?
Yes. And we also know that the primary quadrant that that's going to give us is the first. So we are taking the tangent of a first quadrant angle, and we should get a positive number, and we do.
Yeah.
So this is the way to do it where you don't actually have to know what the inverse sine of 3/5 is. Most people never know what that angle is. It happens to be 37 degrees and change. Is it 37? Yeah, it's 37, and this is 53. But as common as the 3, 4, 5 right triangle is in math, what is not commonly known are those two acute angles. Because that we don't usually worry about what those angles are. And notice we were able to get the answer without knowing what theta was.
Yeah.
All right.
Okay, next one is determine the quadrant of the terminal side of the angle in standard position. Oh, I know how to do that. That's pretty easy.
Okay.
Alright,
you sure? Because I know how to do those.
Yeah,
okay.
Well, the first one is negative 135 degrees.
Oh.
So that would be a 45-degree angle.
Well, hold on. Negative angles start from the x-axis and they go the other way. They go clockwise instead of counterclockwise. So there's your negative 135-degree angle. Placing it in which quadrant?
In the third.
Exactly. In other words, that's the same as a 225-degree angle, which is in the third. And is nothing wrong with doing that. In other words, always take 360 minus this to figure out what the equivalent positive angle would be, and then you know where that is. But it's easy enough to do when you look at it from a negative angle perspective. In other words, when you go clockwise instead of counterclockwise.
The next one is pi over 12.
What quadrant's that in?
The first.
Okay.
And then, alright, so the point on the terminal side of an angle in standard position gives the smallest positive angle measure in both degrees and radians, and it's root 3 and 1.
All right. What they're saying here is that there's some angle where that thing would have coordinates root 3 comma 1.
Yeah.
You know how to figure out that angle?
It's up 1 and over root 3. So you could draw in the triangle, right?
Well, okay, let's look at doing that. If I draw the triangle, this is up, this is root 3, excuse me, this is root 3, this is 1. Obviously, we're in the first quadrant, but they want this angle, right?
Yeah.
How can I get that angle?
By taking the tangent of it?
Well, I'm going to need, the tangent of theta is 1 over root 3. So theta is what? Which of our special triangles does that fit?
That fits a 30, 60, 90?
Yes. Which angle is opposite the 1?
That would be the 30 degree.
Yeah. I call those my unit special triangles, and the reason I call it that is because opposite the smallest angle is always 1.
Yeah.
Okay? And then, of course, radians, pi over 6. Okay?
All right, next one is evaluate the expression exactly without a calculator, and it's tangent of negative 135.
There's an easy way and a hard way to do these. Let's save you 2 steps. The tangent of negative x is equal to what? Or the tangent of negative theta? It's equal to minus tangent of theta. Because it is an odd function. It's not even. If it was even, like cosine, in other words, cosine of negative theta is equal to cosine of theta. However, sine is also odd. So sine of negative theta is equal to negative sine of theta. Tangent and sine are both odd. And if you use that property here, it shortens the problem considerably. So tangent of negative 135 is the same as minus tangent of 135. What's the tangent of 135? What quadrant's that in?
That's the second.
What's the equivalent first quadrant angle?
45.
What's tangent of 45?
1.
What's tangent in second quadrant, plus or minus?
It's minus.
So I can replace tangent of 135 with minus 1. Minus times minus 1 is plus 1.
Yeah.
Now let's look at it from a different perspective. If I actually draw the thing like that, where it's minus 135 degrees, I can clearly see I'm in the third quadrant, so I better have a positive answer. And it's always good to check that. In other words, you know what each of your 6 trig functions are in each of the 4 quadrants, whether they should be positive or negative. And so you can always add that last ballpark check pretty easily. But notice that if I were to do this the hard way, first I would turn that into a positive angle. So that's the same as the tangent of 225, right? And then I would have to figure out what's the equivalent first quadrant angle here, where it's 45. So that would be the tangent of 1. So it's not that hard to do it the hard way, but there are going to be cases where it's 2 steps longer to do it the translating it to a positive angle than it is to use the properties of odd or even. You want to know those properties anyway, because you're going to end up having problems like, what's the sine of minus x? And you have to be able to turn that into minus sine of x.
Yeah.
So you want to know those odd-even properties.
The next one is cosecant of 270 degrees. So first,
cosecant's reciprocal of what?
1 over sine.
Okay. So let's draw the sine curve. And we know that the cosecant sits on top of the peaks and on the bottom of the valleys. So there's the cosecant curve. So what is the cosecant of 270 degrees?
-1.
Yeah. And the reason we know it sits on that point right there is because the only number, 1 is the only number whose reciprocal is the same thing. So if the sine is equal to -1 at 270 degrees, then the cosecant has to be equal to that -1 also, because the reciprocal of 1 or -1 is the same number. And it's the only number that's like that.
Next one is cotangent of -90 degrees.
So is this odd or even?
Odd.
It shares its odd or evenness with its reciprocal.
So yeah.
So it's odd.
odd.
In other words, because tangent is odd, cotangent's also odd. So this is the same as minus cotangent of 90 degrees. Okay. Well, to get trig functions of your quadrangles, there's a number of ways you can do it without a calculator. I know what the graphs look like. And if you know what the graphs look like, this is the graph of cotangent. And this is pi over 2 right there. Cotangent's always going down, always decreasing, so it's right there. So what would the cotangent of 90 degrees be?
It would be -1.
Negative infinity.
Oh, negative. Yeah.
Right? In other words, it's headed towards infinity as it gets closer and closer to 90 degrees. So this is negative infinity. Negative of negative infinity is positive infinity. Now, they may not like you to use the word infinity. They may prefer you to use the word undefined. They both mean the same thing. I prefer infinity because there's a difference between negative infinity and positive infinity. And yet undefined is used for both. So the more specific answer is actually infinity. At least to me. I'm not sure what your teachers want. They may prefer undefined. Now, I've made a mistake here. That's not the tangent curve. The cotangent curve goes from 0 to pi, not pi over 2. So, at pi over 2, which is right there, cotangent is 0. So this answer is actually 0.
Yeah.
In other words, cotangent has a period of pi. It repeats every pi. Every pi, I can draw a vertical asymptote, and that cotangent curve looks like that, and just keeps repeating on and on and on. but the distance between there and there is pi, not pi over 2 like I originally drew it. Same with tangent. If we want to look at the tangent curve also has a period of pi, but it doesn't go from 0 to pi like the cotangent curve. It goes from minus pi over 2 to pi over 2. Notice that's a period of pi. It's always increasing. Looks like that. This is the tangent. All right.
Next one is use a right triangle to determine the value of all trigonometric functions for theta, where theta equals 15/8.
Where what of theta equals 15/8?
Tangent of theta.
Okay. Now, this is almost the quintessential trig question, where they give you the one trig function's value, 15/8, and they want you to know what the other 5 trig functions of that angle are. Well, the way you always want to do this, whether they tell you to or not, to use right triangles, you always want to use right triangles. Does not matter what quadrant it's in. You want to use right triangles. First thing you do is draw a right triangle and label theta. Now mention that triangle for
me. That would be...
What's this side there?
That would be 15.
What's this side down here? And what's that side right there?
That would be the square root of 15 squared plus 8.
Which is 17. This is a perfect Pythagorean triangle. This is like the third smallest. You got 3, 4, 5. You have 5, 12, 13. And this is the next one up, 8, 15, 17. So now, what is sine theta?
Sine of theta would be 15 over 17.
Cosine of theta?
8 over 17.
Cotangent of theta?
8 over 15.
Cosecant of theta?
Cosecant of theta would be 17 over 15.
And finally, the secant of theta?
17 over 8.
And notice that at no point in time do we know what theta is. We don't need to know what it is. This is similar to that other problem where we had tangent equals 3/5.
Yeah.
But always remember that that's the first step. Even normally what these problems look like is they'll say tangents equal to 15 over 8 and theta is in the third quadrant. Now, sine of theta is negative 15 over 17.
Yeah.
See the difference? Is the moment they tell you the quadrant, it changes the plus or minus sign on a lot of the other trig functions. Tangent's still positive because tangent's positive in the third quadrant. But the sine and the cosine are both negative.
Yeah.
Okay.
And the last one that I have is y equals tangent of 2x, and then it says use transformations to describe how the graph of the function is related to to a basic trigonometric graph.
What's the basic elementary function here?
Tangent of x.
Okay, we know tangent of x goes from minus pi over 2 to pi over 2 as a period of pi.
Yeah.
These are its asymptotes, and I know it's always increasing, so it looks like this. Okay, and there's one other point on here that usually is not put on here, but it should be always, and that's pi over 4 because that's where it's equal to 1. So, tangent of 2x, what are the consequences of the 2?
It makes it half as wide.
Yes, it acts as a horizontal compression factor. More importantly, b is 2, and b is equal to 2, b is equal for tangent to pi over the period. So the period is equal to pi over b. Well, in this case, b is 2, so our period is pi over 2 instead of pi. So if I want to draw this function with a period of pi over 2, I'm going to make my vertical asymptotes go from pi minus pi over 4 to pi over 4. And then I'm going to draw that function as if it were normal looking, like that.
Yeah.
But notice that all of these transformations for trig functions are the same as the transformations for polynomials, functions in x. You got your standard function. This is your sinusoidal function. And for some reason, they don't really teach it this way. I'm not sure why. But A is a vertical stretch factor, right?
Yeah.
C is a horizontal translation, just like it would be if I had y equal x minus 2 squared. The 2 is a translation of 2 units to the right. Well, C is a translation of C units to the right. B is a horizontal compression or stretch factor, and D is a vertical shift, just like it would be if I said y equals x squared plus 2. I know that I'm vertically shifting it up by 2. So there's nothing really any different with trig functions over polynomial functions. The transformations are the same. It's just that they tend to call them and talk about them differently in trigonometry. This relates to the period, this relates to the phase shift, but all of those are just horizontal translations or compressions.
Yeah.
All right, Lucas. Looked like your timing was just right there. You got through all your problems.
Oh yeah, my dad wanted me to ask you, do we owe you anything?
Hold on one moment and I can check real quickly. No, I don't think so. Let's see. Going in to today, I had your balance at 0. So the only thing you owe me for is today's session.
All right.
$32.
Okay.
Okay?
All
right,
right,
Lucas. Talk to you next week. Same time, Wednesday, 4?
Yeah. Yep.
Sounds good. Talk to you then.
Bye.